Okay, now that we've learned how to solve the problems using the chart, we need to solve the problem of not being allowed to use the chart. Right? If you go take a certification exam, they're not going to allow you to take in a chart to help you subnet. Uh, what does that mean? That means we need to figure out how to make the chart because they will give you a piece of paper to solve subnetting problems with. But we, instead of using that piece of paper to do a bunch of tedious binary calculations, what we're going to do is use that paper to build the chart that we can use to solve our problem. So the easiest way to build the chart is we actually have to memorize one of the lines in the chart, and I recommend we memorize the bottom line in the chart, which is /30, right? So let's go up here and put headers. This is our prefix length, right? Then we have our total IPs, and then we have usable IPs, and then we have increments by, right? And you might be saying, well, why don't you have the dotted decimal net mask? Well, we didn't really use the dotted decimal net mask when we were solving the problems, so we're not going to worry with building that into the chart we're going to use for solving problems. So there we go. So we need to memorize the last line. If we have a /30, our total IPs is going to be 4. Our usable IPs is going to be 2, right? Because 4 minus 2 gives us our usable IPs. And our increments by field is going to be 4. So that is the first line of the chart. We go up for the prefix length. We'll just, subtract 1 every time. Subtract 1 every time. And we'll stop there. We don't need to build the whole chart. If you start building the chart and you get all the way to /8, that's a lot of time you wasted when you might not even get a question that needs a /8. So in order to find the total IPs, it's a simple process of doubling the number you have every time you go up. So with binary numbers, every time you add one more binary number to your one more binary digit to your available number of digits, that doubles the possible values you have. So if we had 4 for /30 total IPs, we'll have 8 for /29, and we'll have 16 for /28, and we'll have 32 for /27, and we'll have 64 for /26, and we'll have 128, 256, 512, 1024, 2048, 4096. And if you can't remember these numbers, it's easy enough. Just times 2 or add it to itself every time you go up. So I'm going to stop at /20. If you're solving some problems on a test certification exam, you realize you need more than /20, then go ahead and continue your chart by all means. That's 8192. Usable IPs is going to be found by subtracting 1 from the total IPs. So if we had 8, 6, 16 minus 2, did I say minus 1? I mean minus 2. 16 minus 2 is 14. 30 minus 2 is 30. 64 minus 2 is 30. 62, 128, 126, 256, 254, 512, 510, 1024 is 1022, 2046, 4094, 8190. So that gives us our usable IPs. Increments by field is a little more tricky since we write our dotted decimal numbers. Since we write our IP addresses in dotted decimal, then we work within each octet. So depending on what octet we're in is how much is when our increments by is going to change. So we're going to put a gap between 24 and 25 because that's where it's going to change. So with the increments by, same thing. We just double it as we go up to a certain extent. right? 16, 32, 64, 128. So we stop at 128 because once we go to the next number up, we have moved over into the third byte. So in this case, we're going to start our increments by field over again at 1, and then double it as you go up. And if we kept going all the way, we would have 64 and 128 as well. So that is how you can build a facsimile of the chart that you can use while you are taking tests of any particular type. So this, in my opinion, is much easier than doing binary calculations.